Okay, so today I'm going to demonstrate to you a web application that has been developed by Professor Paul Amman and Jeff Hoffer's group. And through this web app, basically, you can specify a graph in the desired text areas and text fields, and then you can find out the test requirements for nodes, edges, edge pair, simple parts, prime parts, and likewise you can also compute the test parts for achieving those uh, coverage criteria like node coverage, edge pair coverage, and prime path coverage. So they have two algorithms on the back end. The first algorithm is slower, but it gives you more test parts which are shorter, and the second algorithm is faster, but it comes up with fewer test parts which are longer. So let's switch to the web app and see how it works. So here you can basically retrieve it from this web address. I will also provide this web address in the description of this video. Then it has three areas of input. First one is this text area. Here you need to provide the edges of the graph. The next text field is in the center column of the web application. Here you need to provide the initial nodes of the graph, and if it has more than one initial nodes, then those can also be input, but those must be separated by a space. Likewise, you also need to provide the final nodes of the graph, and if they are more than one, they can also be input in this text area, but they must be separated by spaces. Then you can look for these test requirements. You can find out the test requirement for the nodes, the edges, the edge pair, the simple parts, and the prime parts. And as I just mentioned a short while ago, there are two algorithms, algorithm 1 and algorithm 2. These can compute the test parts for node coverage, edge pair coverage, and prime path coverage. And so let's work out an example. I'm going to erase all the ink on the screen at the moment, and I will draw a graph for just you people to have what I'm trying to do. Otherwise, we worked out the prime parts on this example in the last video. So the graph was like this. It has this node 1, it has another node 2, node 1 was connected to node 1, then it had a node 3, it was connected to node 1, and then node 2 was also connected to node 3, and node 3 was connected to node 4, which was connected to a node 5, and there was a cycle between node 5 and node 6, and a final node 7 was also there. We can show it by double concentric circles. So this was connected to node 4, and this was also connected to node 5. So if I want to compute the test requirements and the coverage test parts for different coverage criteria, I need to input all these edges. Let me highlight these in different colors. For example, this edge, this edge, this edge, this, and these two edges. Sorry, into this text area here. So I have already copied these edges onto the clipboard. So let me input this here. So these are the edges which I have pasted, and this graph just had one initial node, that is the node number 1. I can just input that here, and it had the final node 7, which I input in the final nodes text field. Now I can move on to find out the test requirement for the nodes. So now you can see here on the left, it lists all these nodes, which are required to be covered for achieving the nodes coverage. In the same way, if I want to compute edge coverage, then I just click on this and you will get all the edges which need to be covered to achieve edge coverage on the graph. In the same way, if I want to find out the test requirements for edge pair coverage, I will click on this button, and now you can find all the edge pairs which are required to be covered for achieving edge pair coverage on the graph. So for the moment I am removing the graph which I made on the screen, because the same graph can be drawn by the web app itself. So if I want to find out the simple parts on this graph, so these are listed here, and these are 31 parts, and you might wonder why these are 31, because in the last example which we worked out in the last video, there were 38 simple parts. It is because this web app is not considering the parts of length 0, which we also worked out in the example. So if we include those 0 length parts, those will be node 1, 2, 3, 4, 5, 6 and 7. So that will add up to this 31, and you will get 38 simple parts. So for the sake of this web application, we can just forget about those and work with these length 1 and more parts for working out the example of prime path. Now we have seen the simple parts, we have seen the edge pair, we have seen the edges, and we have seen the nodes. So what we find when we click on the prime parts, so we worked in the example last time that there were 9 prime parts on this graph. So those all the 9 prime parts are listed here. You can see those, and here you can see actually that we have these parts which go through the loop more than once, and also those prime parts which don't actually make the loop iterate even once. So now we are interested in finding out the test parts that will achieve the different coverage criteria which are mentioned on the top of this graph. So for example, if I want to find out the test parts that achieve node coverage, then I need to click on this node coverage button. So from here, now you can see it has given me 2 parts. Two test parts. First one is 1, 2, 3, 4, 7. So this is 1, and let me erase that. I drew it in the wrong direction. So 1, 2, then 3, and then 4, and then 7. So by this test path, we covered these 1, 2, 3, 4 and 5 nodes, and there are still nodes left. Those are 5, 6 and node 5, 6 are not covered by the first test path. So we also mark the nodes covered by the second test path, and I change the ink of my pen. So those are 1 to 3, then 3 to 5, then 5 to 6, then 6 to 5, and then 5 to 7. So in this way you can see that all the nodes of this graph have been covered. Now if I want to compute the edge coverage on this graph, here you can see the web application has listed these 3 test paths. So you can remember from my earlier video that a test path must always begin from the initial node and it must end on a final node. Initial node in our case was 1 and the final node in our case was 7. So the first test path actually takes you from node 1 to 3, then 3 to 4, and then 4 to 7. And here you can see that we have covered 3 edges on which I have drawn a line. and if you take the second test path, that takes you from node 1 to 2 to 3 to 4 to 7. So we covered 2 more edges. Now let's think about the last path, that was 1 to 3, 3 to 5, 5 to 6, 6 to 5, and then to 7. So now I have covered all the edges which were not covered by the first two test paths. So in this case, these 3 test paths are enough to cover all the edges on this graph, and in this way you can try all these criteria: node coverage, edge coverage, pair coverage, and the prime path coverage. Now I will switch to the more interesting one, the prime path coverage. If you click on the prime path coverage button, so I get a whole lot of stuff on the left of the screen, which I would like to go through one by one. So the first test path is listed here is this one. It is 1, 2, 3, 4, 7. I have marked it with a pink label. So if I traverse this path on the graph, it goes to 1 to 2, 2 to 3, 3 to 4, and 4 to 7. And on the right column of this table, you can see the test requirements that are covered by test paths directly. So here it is mentioned that this is the prime path 1, 2, 3, 4, 7, which has been covered by this test path, which is in the left column directly. It means it doesn't take any side trips, the concept we discovered in the second last video, and a detour. And this is obvious from the graph that this path has been taken in this way, and this path doesn't leave the prime path 1, 2, 3, 4, 7 and goes to another node, either the successor of some node or the same node. Therefore there are no side trips or detours involved in this test path, which I just marked on the left in the left column and in the first cell of the table. Now let's take another example where some sort of side trip is involved. So I removed all the ink from the screen, and here you can see this looks an interesting case. Here the test path is 1, 2, 3, 5, 6, 5, 7. So 1, 2, 3, and then it goes to 5, then go to 6, then again goes to 5, and then goes to 7. And I will use another ink to mark the path. So the path is 1 to 2, 2 to 3, 3 to 5, and 5 to 7. Now you just need to look at the pink lines. These are going along 1, 2, 3, and then 5, and it leaves the blue set of lines at node 5, and then come back again on the node 5, and then continue along the blue set of lines towards node 7. So this is exactly the concept we studied in the case of a side trip. What do we mean by a side trip? When the test path leaves the prime path from a node and comes back to the same node and then continues along the prime path, then such a test path is said to be touring the prime path by means of a side trip. So this is how we can make use of this web app for different sorts of test requirements and different sorts of coverage criteria. You can also take advantage of these two algorithms. One of them is slower but has shorter test paths and more test paths, and the second one is faster but it gives you fewer test paths and longer test paths. So that is all for today's video. In the next video I will come up with data flow coverage in the context of white box testing. Thank you.